Okay guys, so next support we have what we call as improper functions. Okay, so for example, if you have like the fs equivalent to the s squared plus the 4s plus 6 divided by the s squared plus 3s plus 2, so you can see that obviously these functions fs is an improper functions because the degree of the numerator and denominators are the same. Therefore, this is an improper functions. So you have to first change from an improper functions to the proper function first. And what do we do for that? So we will apply the method which called the long division method to make the improper functions into the proper functions. So we will start with the s squared plus the 4s plus 6, and then we apply the long division method, and then the divider is the s squared plus 3s plus 2. So now you can see that we have the s squared and we have this one is the s squared as well. So what is the value that make the s squared equivalent to s squared? Right, the value of 1, right? So after we know the value, then we multiply that value to each of the term for the divisions functions. So s squared here multiplied with 1, we get the s squared. So 3s multiplied with 1 here, we got the 3s. And then 2 multiplied with 1, we got 2. So after that, we will subtract the two functions. So 6 minus with 2, we got the positive 4. And then 4s minus with the 3s, we got 1s left. And that's it. So 1 minus 1s squared minus 1s squared, so that's become 0. And now you go back, check the remainder with the s squared here. So as you can see that in this case, the value of let me change the color for you. So here we got the s squared raised to the power of, we got the 1s, and in this case we got the s squared, so 1s is less than the s squared. Alright, then we stop at this step, and then we rewrite the expressions of the fs, which is equivalent to s squared plus 4s plus 6 divided by s squared plus 3s plus 2, and that becomes equivalent to 1. You have the result, that's it, the one, you just write 1 first, and then you write the addition sign. So we will start with the functions of the remainder first, which is the s plus 4 divided by the divisions functions, that is this one, the s squared plus 3s plus 2. So now you can see that we have two functions. The first one is the value of 1, and then additions with the s plus 4 divided by s squared plus 3s plus 2. So you can see that the last functions or the last term here, so this one, so now is it the proper functions. Alright, so if it is proper functions, then you can continue the techniques we discussed earlier to find the inverse Laplace transform. Okay, therefore in this case we will find the partial fractions of that s plus 4 divided by s squared plus 3s plus 2. So from that explanations, we suppose, let's say this one as the s divided by 4 divided by s squared plus 3s plus 2, and that becomes equivalent to the s plus 4 divided by, you know that we need to have two functions multiplied together, and obviously this one is the functions of the s plus 1 plus the function of the s plus 2. Alright, so in this case, you go back to the first steps, and we see that we have got the maximum degree of 2, which means that we need to variable, we need to constant in this case. Therefore, just like the first one, add the a divided by s plus 1, adding up with the b divided by s plus 2. That is the first step. Alright, and then the second step, you multiply the term s plus 1 and s plus 2 on both sides. Okay, you multiply that on both sides of the expressions. So here is what you will have. So you will have s plus 4 divided by s plus 1, and then multiply with the s plus 2. So you multiply that. So you multiply that on both sides of the expressions. Right, so you have a divided by s plus 1, adding up with b divided by the function of the s plus 2. But that term you will have to multiply by s plus 1 and the s plus 2. Right. Okay, so now you can cancel this one and this ones. Likewise, the s plus 1 terms will be eliminated out. For this case, the s plus 2 will be eliminated out. Therefore, on the left side of the expressions, you will have the s plus 4 equivalent to a multiplied with the s plus 2, adding up with b multiplied with the s plus 1. And after that, you will need to cross multiply the constants a and the constant b on both sides of the expressions. That's for the second step. And then the third step here, you will have to figure it out the same group, which means that the highest degree here on both sides of the expressions is 1. So which means that you have to look for the terms that have the combinations with the s here. So that is this one and this one. So you group that at the first group. Alright, and then the remaining terms will be for the second group. So that will be 4 equivalent to 2a plus b in this case. So this s, and this s can be deleted out. So you will have 1 left equivalent to a plus b. And therefore, the value of a will be equivalent to 1 minus with the function, the constants b. And then makes that at the first expressions. So after that, you will substitute the value of a, which is equal to 1 minus b, back to that second group. So you will have 2 multiplied with a. Now we have changed into 1 minus b, and then adding up with the value of the b. So then you have 4 equivalent to 2 minus 2b plus the value of b. So 2 here, move to that side, it will become 2, and then minus 2 plus with 1, so you got minus b. Therefore, the value of b here is equivalent to minus 2. So after you know the answer or the solution for the b, then you substitute that back into the first expressions. So in this case, our value of a here will be equivalent to 1 minus with minus 2. Therefore, the value of a will be equivalent to 3. So after you know 2 solutions for the a and for the b, then you will go back to the first step here, and we will change that a as the value of 3 and that b as the value of 2. Right. So in this case now, we will have a equivalent to 3, and the value of b here will be equivalent to the minus 2. So now we will have to rewrite the fs, which is equivalent to 1, remain the same, right? And then adding up with 3 divided by the s plus 1, and then adding up with the minus 2 divided by the s plus 2. So that is our fs. So now after you got the relational functions, and then you need to find the inverse Laplace transform to that the fs. So again, the value of 1 here. So 1 means the impulse response or the dialects. So that's become these functions, and 3 here is the constant, and that will be multiplied with the exponentials of the negative 1 multiplied with the t, and minus 2 as the constant will be multiplied with that 1 divided by s plus 2, and that s plus 2 in the s domain, invert that into the time domain, so which will be equivalent to the exponential of the value of minus 2t. So that is the solutions or the inverse functions of the Laplace transform for that fs functions. Okay, so I hope you understand how can we first change the proper functions into the how to change the improper functions into the proper functions, right? So again, let me give you the second example of the improper functions. Okay, so here in this case, example 2 for the improper functions. So when you have like the fs equivalent to the s squared plus 7s plus x divided by s squared plus 3s plus 2. So obviously this is an improper function. So you have to make that into the proper function first by using the long division method. So you will start with the s squared plus 7s plus x, and then you use the long division method, and that is the division functions. So again, you have to find what is the value that multiply this s squared and return you this s squared. Again, the value of 1. And then after you know the value of 1 here, you will have to multiply 1 on every terms of the division functions. So you will have s squared, and then adding up with 3s, adding out with 2, and then you subtract that out. So x minus with 2, so you got the value of 6, and then 7 minus with 3, you got the additions of 4s. So you stop at the process, and then you go back and check. So we have the 4s, where the degree of this 4s is the degree of 1, but that is the degree of 2. So the degree of remainder is much lesser than the degree of the denominator. Then we stop up this process, and we realize the expressions in terms of the solutions. That is the 1 first, and then you adding up with the remainder, that is this ones. And we see the 4s plus 6 divided by the divisions or the denominator, which is the s squared plus 3s plus 2. So you can see that the degree here is the s, degree here is the s squared, which is much lesser than the denominator. Then we stop up this process. Okay, so suppose you have like the s squared plus 7s plus x. Okay, these ones. Okay, and then okay, like plus 2. Suppose you have 4s squared, right, for example, plus 6. So you can see that when we want to rearrange the s functions, we will have 1 adding up with 4s. We have 4s squared plus 6, that is the remainder, divided by this one divider, which is the s squared plus 3s plus 2. You can see that that is still s raised to the power of 2, and that is still s raised to the power of 2. The degree here and the degree here is the same. Therefore, you cannot stop at this process. You have to continue finding until the degree of the remainder here is much lesser than the degree of the denominator. Right. Okay, that is how we perform these kinds of improper functions. So next, after we got the new functions of the S domains, okay, so we can continue finding the relational functions or the partial fractions of that case. So in this case here again, you know that we need to have two different variables because the degree here is 2. Okay, the highest degree of the denominator is 2. Therefore, a maximum 2 variable is required. So we will change that into A and into B, 2 variable. So here we have s squared plus 3s plus 2. So we got one for the s plus 1s and another one for the s plus 2. That's it, the first step here. And the second step, you cross multiply s plus 1s and s plus 2 on both sides of the expressions. So you will have the s plus 1s multiplied with the x plus 2, right, on one side, and then you will have to multiply that on both sides of the expressions. So that will be s plus 1s, s plus 2. That will be the s plus 1s, s plus 2. So in this case, you can cancel that out, cancel the s plus 1 and also delete the s plus 2. Therefore, your remaining terms will be for s plus 6 equivalent to a multiplied with the s plus 2 plus b multiplied with the s plus 1. And then you cross multiply the a and the b back into that parentheses. So you have 4s plus 6. So now the third method here, you have to look for the maximum degree first on both sides of the equations, and we found that 1 is the maximum degree. Then we look for the terms that has the maximum degree of 1 and then maximum degree of 0, and then we will group them. So for the maximum degree of 1 on the left hand side, we got 4s. On the right hand side, we got the AS, and then adding up with the BS. So we form the first group. And then the remaining term here will be for the constant. So that is 6 equivalent to 2a plus b. Alright, so that's S can be cancelled. Therefore, you will have 4 equivalent to a plus b left. Therefore, let me say our a is equivalent to 4 minus b. Right, and then make that at the expression 1. So now you will multiply the value of a with the 2. But in this case, we know that from expression 1, a is equivalent to 4 minus b. Therefore, we replace that. And then adding up with b. So you cross multiply 2 inside the parenthesis. You will have 4 multiplied with the 2, you got the x, and then minus 2b plus b. So you have now you have now the value of the 6 minus x, which is equivalent to minus 2b plus b. So so 6 minus x, you got the minus 2, and then that becomes the minus b. Therefore, b is equivalent to minus b is equivalent to minus is equivalent to 1. B is equivalent to 1. So after we know the value of b, which is equivalent, no, it's not 1, right, it's not 1. So we got minus sign here, so minus sign can be deleted out. Therefore, in this case, our b is equivalent to 2. So after we know the value of b is equivalent to 2, we substitute that back to the expressions number 1. So we have a, which is equivalent to 4 minus with the 2. Therefore, our a is equivalent to 2 as well. Right. So now we got everything in hands, and then next step we will substitute the value of a and b back into that expressions here, these expressions. Right, so we got a, which is equivalent to 2 divided by s plus ones, and then we got also b, which is equivalent to 2. So then we will have the value of the a and the b that is exactly the same, which is 2. So now the fs is equivalent to 1, adding up with 2 divided by s plus 1 plus with b, where b in this case is 2 as well, divided by the s plus 2. So now you got the fs. Therefore, we can find its inverse Laplace transform. So 1 here, inverse Laplace transform of 1 here is the value of impulse response plus 2 multiplied with the exponential of minus t, and then you have plus 2 multiplied with the exponential of the minus 2t. So that is the final solutions for these functions. So in this case, I want you to make the corrections for this slide here. Okay, this one. Right, it's already correct. Okay, that is plus 2, that is plus 2. Okay, that's fine. So now we will go back to our third example for that of the improper functions. So our last example for the improper functions. Here, suppose you got the fs equivalent to 2s squared plus the s and then plus the 3 divided by s squared plus 4s plus 4. So again, in this case, it is the improper functions. So you have to make it into the proper functions by using the long division method. So you start with the numerator, which is 2s squared plus s plus 3, and divide by the denominator or the divider, which is the s squared plus 4s plus 4. So now you have the s squared, you have the 2s. So what is the constant that make the s squared become equivalent to 2s squared? Right, that is the value of 2. So after you know the value of 2, you have to cross multiply 2 for every term of the denominator functions. Therefore, you will have 2s squared, and then adding up with 4 multiplied with 2 is x, and then adding up with 4 multiplied with 2, that is also equivalent to x, and then you subtract the two functions. So 3 minus x, that becomes minus 5, right? And then 1 minus with the x, that becomes minus 7s. Okay, so you can stop at this step. Why? Because the degree here of the 7s is less than the degree of the divider, that is the power of 2. So next, you can rearrange the expressions into the result here with E2, and then adding up with the remainder, that is minus 7s, and then minus 5 divided by here the denominator. You can see that the functions of the denominator here remain the same. Okay, but the things that has changed is the result here and also the denominator, which we have to make its degree to be much lesser than that of the denominator, and then you can continue finding the partial fraction process like what we did before. So that is how the improper functions will be performed. Okay, so let's continue with this case. So as you can see here, we can also separate, or we can have a look for the root of the s squared plus 4s plus 4. And here, if you continue finding, you will have the degree or the root here that is equivalent to s plus 2 raised to the power of 2. Okay, which means that in this case, you can separate them into the s plus 2 for one term multiplied with the s plus 2 for the second terms, and that become the repeated root like in this case. So for sorry, for that case, you have the repeated root, and then we use the second case, which is the repeated root, to continue finding the a and the value of the b. So why a and why b? Because we know that obviously we have the highest degree of 2, so which means that we need to variable in this case. Therefore we will have to find the terms for that functions here. So now let's say that we have minus 7s minus 5 divided by the s plus 2 square. So that in this case it will become a divided by the s plus 2 square for one term, and then adding up with b divided by the s plus 2 raised to the power of 1 for another terms. And then that's it, the first method. The second method, you have to multiply the s plus 2 square on both sides of the expressions, right? So we got 7s minus 5 divided by the s plus 2 square, multiply that by the s plus 2 square, make that equivalent to a divided by s plus 2 square, multiply with the s plus 2 square, plus b divided by s plus 2, multiply with the s plus 2 square. So this and this and this can be deleted out, so that and that we have the degree of 1. So on the left side of the equations we will have minus 7s minus 5 left, and then on the right side we will have the value of a here left, and that add with the b multiply with the s plus 2 raised to the power of 1. So now you will cross multiply b inside the parentheses, you will have these functions left. Okay, so the third step here, you will have to group the same coordinates, which means that the higher degree in this case is 1, so you will have to look for the terms that consist of the s raised to the power of 1. So on the left side we have the minus 7s, and on the right side of the equations we have the bs left. Okay, and then the remaining terms here will be for the second group, which is the minus 5 equal to a plus with the 2b. So this s here and this s here can be cancelled out, therefore the b is equivalent to the minus 7. So now for the second group, we have to find the value for the a, and then in this case we can substitute the value of b as the minus 7. So we will have a, and then 2 multiplied with minus 7, it becomes minus 14. So if you move 14 here to that side, that will be minus 5 plus with 14 equivalent to a. Therefore, our value of a will be equivalent to positive 9. So you can see we got a and we got b. And next step, we will substitute a and b back into the correct position there, right? So in this case, we know that the value of fs, which is equivalent to a, but our a here is equivalent to 9, so we can substitute 9 here divided by the value of the s square, and then adding up with b. So our b here is minus 7 divided by the s plus 2. But again, that is not correct. You have to add with the value of 2, right? Because our fs here actually is equal to 2 plus that term, but we found that that term here is equivalent to this term, but the value of 2 here can just remain the same. Therefore, the inward Laplace transform of the fs in this case is equivalent to, again here in this case, as you can see, we have 9, and then that will be multiplied with 1 divided by s plus 2, the whole of that square. So we have 1 divided by something square. So which means that we have to employ the lamp functions, right? That is 1 divided by the s square. So it's sorry, no, not that. We have to employ the lamp functions. That is the ft equivalent to t. So when you apply the Laplace transform, your fs here will be 1 divided by the fs squared. So in the fs term, we got some things divided, we got 1 divided by some things raised to the power of 2. So that will become the value of t, right? So in this case, we will have the value of 9 multiplied with t, which is 1 divided by the s squared, and then that 1 divided by s plus 2 is the same as the f of t equaling to e raised to the power of at, which is equaling to 1 divided by the s sorry, that should be plus, oh, no, that should be minus, so that become plus. Okay, so therefore you got 9 multiplied with the t, and then also need to multiply with the exponential of minus 2t, right? So 7 again, it becomes minus 7 here. So multiply with 1 divided by the s plus 2. So s plus 2 here, that's it, the s minus 2t. And the value of 2 here is the value of 2 multiplied with the dialects or the impulse point here, this one. So this is our final solutions for this example. When you have the improper function here, you have to make the improper function into the proper function first by using the long division method, and then you have to double check whether your remaining terms, its degree is less than the degree of that of the denominator or not. If that is, then you can continue findings step 1, step 2, and step 3. But if your final remaining term, if the degree is still the same as that of the remainder or still greater than, you have to continue finding further step, right? So that is the improper function.